The question of why we cannot divide by zero has been explained through multiple perspectives. One intuitive explanation involves dividing a group of objects equally among zero people, which becomes meaningless, right? From a more mathematical perspective, division by zero can lead to contradictions that would break rules of arithmetic. However, one perspective I haven't seen explore this often is through the construction of the rational numbers. So in this video, I'll use some heavier math, but I'll try my best to communicate it clearly. So, informally, a rational number is any number that can be represented as a ratio between two integers, say a and b, and can be written as a divided by b. If we take b to be 0, then we are essentially performing division by 0, right? So we'll explore this idea using a formal construction. So first we need to construct the rational numbers. One particular way is to define it as a particular set of equivalence classes, but more on that later. First, we need to develop some terminology and tools to be able to get to that. Suppose now that we have a non-empty set S, and now we can define something called a relation, which we represent as tilde on a set S. Is basically any subset of the Cartesian product of S with itself. And then elements of this subset, say x comma y, we then will say is, like for example, x is related to y. Now, for the relation, if we add the additional properties that the relation is reflexive, symmetric, and transitive, then we have something called an equivalence relation. Now, take a particular element A in S. Then if we gather every element in S that is related to A, that is if you take B and S such that B is related to A and form a set from it, then this set is called an equivalence class of A, which then we represent as bracket A. So essentially what you're doing is that you're partitioning the set and grouping all those elements that are related to each other under the equivalence relation. The set of all equivalence classes for S under the relation is called the quotient set, or just the set of equivalence classes. So now we can construct the rational numbers using these tools that we just learned. So how can we do that? Well, first we need to take the set S to be the set of all ordered pairs A comma B, where A is an integer and B is an integer, but B is not 0. Then we can define a relation on that set by saying that any two ordered pairs A comma B and C comma D are related if A times D is equal to B times C. Now, this might look familiar because this is exactly what we end up with when we do cross multiplication on the stuff like A over B equals C over D. Now, this is where we can start constructing the rationals. For a given pair, A comma B, take the equivalence class of it. In other words, all ordered pairs that are related to it under that relation. And now we can define a rational number to be exactly that equivalence class. In other words, A over B is defined to be the equivalence class bracket A comma B. From here, you can give it a ring structure where we have addition and multiplication in the usual sense to get how we add and multiply fractions. But we're not interested in that right now. We can just take the quotient set and look at the set of all equivalence classes. So basically this set that we just constructed is basically the rational numbers. So note that for this construction, we actually didn't even make any use of actual division. And also the set S had a constraint on it. In particular, B could not be 0. So the reason I did that is because if we did that, then we're saying we're dividing by 0, right? A over B, where B is 0, means division by 0. But with this construction, there really is no reason why we cannot add in 0. So let us do that and see what happens. So if we do that, we actually get a particular pair out. That pair being 0, 0 is now in the set. So now let's take a look at this. take an arbitrary element in the set S, or in the relation S, x comma y. Now, is x comma y related to 0 comma 0? Well, for that to be true, that means that x times 0 has to equal 0 times y. But that is always true, no matter the values of x and y. Therefore, every pair x comma y is related to 0, and thus the equivalence class bracket 0 comma 0 has every ordered pair in its equivalence class. And therefore, every single pair is now stuck inside this equivalence class. And so if we take the quotient group and we actually see what's happening, the quotient group just becomes a singleton bracket 0 comma 0. So what happened? So essentially what happened is that by adding in 0 0, we took something that creates the rational numbers and basically collapses the rationals down to a singleton set. So allowing division by 0 basically destroys the structure of the rationals for this argument. And that's why we cannot divide by 0 through the perspective of the construction of the rationals. And this can easily be extended to the reals. So I hope you enjoyed this video. Drop a comment if you have any questions, or if you'd like to see any other math topic for me to talk about. And don't forget to like and follow. I also have a set of LaTeX notes, and if you want that, DM me, and I'll be happy to send that to you.